99. Write each definition as a biconditional statement. 19. A catcher is a baseball player who is positioned behind home plate and who catches throws from a pitcher. Okay?
No, because you don't just catch from the pitcher.
Not just, it doesn't say just, but he does say who catches throws.
Yes.
Is that true? Okay, so let's write it as a biconditional statement. So let's first write it. Let's write what they're saying. A catcher is a baseball player. A catcher is a baseball player. Okay? Okay? What else are they saying? A catcher is a baseball player whose position is behind home plate. Position is behind home plate. Okay? Alright? And catches from the whatever. Pitcher. Okay? So let's try to write this as a conditional statement first. Then we'll try to do it as a biconditional statement. So the conditional statement, if they're a catcher, then they're behind home plate and they catch the ball. Right?
Yeah.
They're behind home plate and they catch the ball. Okay, that's a conditional statement. Is that true? If you're a catcher, you're behind home plate and you catch the ball. Is that true?
Yes.
Okay. All right. Then, let's write the inverse.
What up, Rennie?
Converse. What's the converse?
Okay, so converse is just a flip.
Yep.
Okay, so
If H and C, right? If you are behind home plate and you catch the ball, right? If you're behind home plate and you catch the ball, then you're the catcher.
No.
Yeah, I was gonna say no.
What if you're the umpire and you catch the ball? Huh? What then?
Yeah, that's possible.
Oh.
Probably not likely.
What if
But we're just trying to write the conditional statement. But yeah, that would be a great counter example for it not working. Okay? So and I love that. I want you guys using that. So one, write the biconditional statement, and then you can tell me it's false and tell me why. Well, the umpire could have caught the ball. He's behind home plate.
Could have caught the ball.
There you go. The ball boy could have came out there and caught the ball. Alright? So, how would you write this conditional statement, this biconditional?
You'd be surprised. I got subbed out. Skyler went in for me. Fucking the umpire.
Okay, how would we write this as a biconditional now? How do you write it? C.
The other sentence there.
The double arrow?
then the H, not C.
H dot C.
You say H, Nazi?
Oh man, I used C twice, didn't I?
Yeah.
I should not have done that, should I have?
It's okay, we understand.
Yeah,
I
that's true.
understand English.
I don't understand.
Just don't pay attention.
But let's change this to a B.
I'm taking notes.
Oh, not writing. I'm trying to look at it and
If
understand.
you write it, you might understand it. I didn't know this today.
Ooh, that's coming
Catches the ball.
Yeah.
Okay, catches the ball. Let's change that second C to a B. He catches the ball. Okay? Sorry about that. Sorry about that at home. You're going to have to rewrite it. That's what erasers are for. Hello. Alright, there you go. 19. Let's go with the next one. 21. 21. Alright. Help me out, Mateus.
What's good?
If 3x minus 2 equals 13. 21.
21?
If 3x plus 2 equals 13. Is that what it says? 3x minus 2 equals 13. Then 4/5 x,
You said 3x minus 2?
3x minus 2 equals 13.
That's how boys be.
Then 4/5 x, guys, focus, please.
Yeah, focus.
4/5 x plus 8
Equals 12.
equals 12. Is that true?
I don't know.
Okay, so they're saying determine if the biconditional statement can be written. If not, give a counter example. Okay? So in other words, let's solve for x here real quick. So 3x equals 15. X equals 5, right? Okay? Then this would be 4/5 x equals 4, right? And then I would multiply by 5/4. And we would get x equals 5. Is that true?
Yeah.
So in both cases, x equals 5, right? So then they actually do equal each other, right? So what can we write? This is a true biconditional statement. That way this can be like this and we're done. Look at that. Something that long, you don't even have to write twice because all you did is do what? You changed this arrow to a double arrow. That's it.
So it goes both ways?
So it goes both ways.
Like a bisexual.
What? Yes.
Wait,
Like yourself.
We gotta hear things.
yes, we are.
Shut up. Why
Right.
you gotta be so rude?
It's okay.
Yeah.
It's okay. It's not a bad thing.
I'm gonna fight
Good
you.
thing.
I'm gonna fight right
She
you.
is.
Nothing wrong with that.
I'll have Rosa choke you out. She'll fucking choke slam you.
Woo!
She's sitting over there like she will.
23!
MMA,
23! This is gonna be just like pre-cal
Stop
on
talking.
the internet. There's a, Dante, shut up. Dante, be quiet. It's like Mateus, shh. Skylar, quiet.
I am fucking talking. I'm telling Dante you're talking
Joking.
shit. Yeah.
What?
I'm telling Dante you're talking shit right now.
Always talking shit. Alright, so 23. If x is greater than 0, if x is greater than 0, right?
X squared is greater than 0.
Then x squared. Is that true? If x is greater than 0, then x... Yeah, so what's the biconditional statement? Bam. Done. It's that simple. That's all I'm looking for. Do you know the difference between a biconditional statement and a statement that's false? If it's false, give a counter example.
It's not nice.
Okay?
Because you know what nice is.
Wash out booty.
Here, we're going to do 22 really quick. Oh, shoot, we're out of time, huh? All right, 25. A definition is square and not squares. Okay? Here it is. 25. Square and not squares.
Who's starting shit?
You know?
Skylar?
Wait, it doesn't look
Yeah. Yes.
People would always tell me that.
Monique?
No,
Okay? So, basically, if the sides are equal and they're all perpendicular, then you are a square. If one of these is not the case, if not S or not parallel, then not square. And that's what they're looking for. Okay? So, if B is square, you have to have all your sides the same, they have to be perpendicular. In this case, two sides are the same, and all four are not. In this case, all four sides are the same, but they're not perpendicular. These two cases are not squares. This case is. If to be a square, then that means that your sides have to be equal, and they have to be perpendicular to each other. Okay? If one of those, either one, is not true, then it's not a square. Done. And that is biconditional. Goes both ways. Okay? Let's finish that up.